Alright, so the tricky part about having these absolute values with the inequalities is remembering that sometimes you have something that looks like an and in the end, and sometimes you have something that looks like an or as when you're representing your absolute values with your inequalities. If I have the absolute value of something is greater than, that one ends up being translated as an or. So, absolute value greater than A, make these into ors. If I have absolute value less than A, those look like ands. So let's just see what I mean by an and and an or. So I got absolute value of 2x minus 5 is greater than 3. So when I get down to my absolute value, I split this up into two inequalities to solve. So one of the inequalities is going to be 2x minus 5 is greater than 3. And it's a greater than, so it's an or. Or 2x minus 5 less than the opposite. So when we set up our second equation to solve, we always did the opposite of the number there. So we still do the opposite, and we do once a greater than the positive number, and less than the negative number. There's some good reasons for that. We can kind of work through theory around that, or we can just kind of accept that and kind of remember that greater thans are ors and less thans are ands. All right, so now I'll go through and solve this compound inequality. I'll add 5. 2x is greater than 8. Divide by 2. X is greater than 4. Or add the 5 and get 2x is less than 2, divide by the 2, and get x is less than 1. So I have x is greater than 4 or x is less than 1. I leave it like that with the or in the middle. There's no other way to write that one. I make myself a number line. That 1 better be on the number line. That 4 better be on the number line and in the right order. I get open dots over both. And I shade greater than the 4. And I shade less than the 1. So my complete answer is the algebraic statement and the graph, the number line graph. Okay, so obviously we're going to do one that's a less than, that's an and next. Okay to go on? Come on. Get to the next page. You can do it. At least it didn't try to like shut the whole thing down. Come on, go to the next page. Ah, there we go. All right. I have a greater than. Hang on. And I lost the page. All right, there was the first page. Come on, don't be goofy. All right. We just have a greater than. I think I got to throw in a less than here in a minute here. So, but now we'll do something a little fancier. So, negative 2 times the absolute value of x plus 1 plus 5 greater than or equal to negative 3. Okay, first step. Yes, sir. Subtract the 5. Okay. So subtract the 5 and we get negative 2 times the absolute value of x plus 1 is greater than or equal to negative 8. How do I get rid of that negative 2? Divide. So I'm going to divide both sides by negative 2 and get the negative 2's cancel and get the absolute value of x plus 1 less than or equal to positive 4. So I did get a less than or equal to. Okay. So less thans turn into ands. So the kind of ands they turn into, you can write in one single statement. I can put the x plus 1 in the middle. I'll use the 4, and I'll use the opposite. And I'll solve the and in that way, which are a little bit easier to solve that way. It doesn't want to do the arrow on the smartboard. I guess it didn't want to do it over here either. Come on, pull the screen down a little bit. You can do it. Okay. Now, might have to write up on the other side. Not sure why that's not responding. Okay, subtract 1 from all sides and get negative 5 less than or equal to x less than or equal to 3. Done with the algebra. This one was pretty simple on the algebra. And now when I go to do my graph, I'll put that over here. I got to put my negative 5 on the graph, my positive 3. I need a closed circle for both. And these are x's between negative 5 and positive 3, so I will shade in between. Okay. Any questions on these? Pretty straightforward for the homework too.